Hey, so I did a crazy thing last night. I already had configured my web servers and I had one worker node using a spot instance. But then this month, when I looked at my server bill, it was over $70, and I said, okay, I want to cut cost by half. So I then decided to move my main server, my main work node to a spot instance as well. And then, lo and behold, I found out that my whole applications on the server got destroyed. So I've been trying to fix it this morning, and I want to walk you through how to set up your own um, web servers using Kubernetes and deploying them on AWS, cost effectively. So today, what I found out is I'm going to switch to a reserved instance in order to save on my compute capacity. So when I come to a reserved instance, I could see that I can only make a reservation for a particular type of instance. So it's either I'm making a reservation for a T3 micro or T2 large or any instance type I'm going to choose. But this is not what I want. I want it to be also flexible. So in case I want to deploy more master nodes, then I would like it to also be covered with the discount. So actually, I have made some research, and the best way to do this is to go for a saving plan. So if you try and buy a saving plan for at least 1 year, then you can save up a lot on your web servers. So let's see how we can purchase a saving plan and then continue. Okay, so when we click on saving plans, then now we can say purchase a saving plan. So now we want to purchase a saving plan. Okay, what do we need? We need the saving plan type. So I want to save on compute capacity. So compute saving plan. All right. Now, I also want to select how long I want to be committed to this saving plan. Then I will say 1 year. All right. Then purchase commitment. So how much are we expecting to use hourly base? So upon research with AI, then the best amount will be $0.045 for me. So because I want to use sorry, what do we call it? I want to use T2 medium for my master node. So I'm going for 0.045 when you run it up. So payment option, then I want to say no upfront. So which means I'm going to be billed approximately $34 per month, which is way better than my compute cost, which was almost around $70 this month alone. So in total for the year, then I'll be paying AWS $406. All right. So now I'll add it to cart. And then I will submit order. Select it, and then I will submit the order. Order submitted successfully. So your order is being processed. It may take a while to charge your payment. If we need additional actions to complete your payment, we will email you instructions. Good. So now we leave the rest to AWS, and then now we can go ahead and deploy our service. So the best thing I have done was to use infrastructure as code. So, the very first time when I heard of infrastructure as code, it was like a rocket science. I was just seeing stars in the beginning, but it all makes sense when you take time to do it once, and then you can always repeat it and modify it and keep adjusting it however you wish. So in case you don't want to deploy your service manually, like I do not want, you can follow along with this script to set up your own web service using Terraform. So I like Terraform to set up my own web service because it's very easy to use, and also it is compatible with almost any cloud provider. So now let's say you want to follow how I have set up my own. You need a variables.tf file which should contain all these variables. So you can pause and then write this down, or you can just copy the code. So you will need an S3 bucket to store your file so you can share with your team. So you need to create an S3 bucket and give it a name. So I have already created my own S3 bucket that I have always been using. And then the next thing you need to do is also the region, and then the the machine image ID. You need that as well. And then we need the instance type. So my main server is going to use a T2 medium, which is good enough for me. And then you also give the key name so you can SSH into your web service. Now we also need to attach a security group to the web server, and then we need to tell it which AZ we want it to be in, the availability zone. Again, we also want to attach a volume size. I need a volume capacity of about 50 GB. And then the next thing I also did was I'm setting up a worker node instance type, which is going to be a T3 medium, because I need a T medium because this is where almost all my applications are going to run. So I need a higher capacity for it. And then it type is going to be a spot instance, because actually I don't really care so much that it will just, when there is no capacity available, AWS will take it back, and then I will still get my applications back running when capacities are available. So imagine if you want to scale your application to have multiple web servers. This is going to be cost effective for you. You'll be able to save a lot on money, so this will be good for you. But if you don't want it, you can also try and make your worker nodes use a T2 medium or T3 medium, which I don't know why you want to pay a lot for that right now. So let's save. And then the next thing we need to do is we need a setup.sh file. I already have a setup.sh file, which is for configuring Kubernetes on my master node. So setup.sh file is responsible for setting up all the configurations that you need. You just don't need to do anything. Everything will be done for you. So now you can also copy this code. You can just pause and copy the code, or you can just copy the code from my GitHub repo. I will have a link in the description down below. So you just have to copy the code now. Now we are setting up AWS CLI. we are updating, and then we are also preparing the kernels, and then now we are setting up the container D as well, and then we will restart the container D. Now we have to install the Kubernetes component, and then now we also need to set up the correct IP in the kubectl kubelet, and then also we will check if all these ports are free. If they are not free, then we have to kill it, and then make sure that before we initialize our Kubernetes on our master node, we are able to run it smoothly and not run into any errors. So that will be it. We will set up the network, and then we also install Helm on it. That will be good, because we need Helm to also install other packages as well. So now I'll save it and then leave it as it is. So the next file that you also need is you also need the Terraform config.tf file. So this is where you are going to provision all the web servers you need. We give the IAM role for the EC2 instance, and then we attach the administrative policy to the role. We also ensure that the server is going to have instance profile, and then now we have to create the main instance. So this is my main instance for my master node. And then the next thing is we add a life cycle. So whenever we say Terraform destroy, we don't want to destroy it to prevent accidentally destroyed. So the next thing, we move on to the worker node. We need to provision the worker node, also give it the tag, and also give it the instance profile as well. And then we also add the policy to it. That is good. Then when you are done with that, the next file you need is the providers.tf file. So you need the providers.tf file, which you are going to tell it which cloud platform you are going to use. So I'm going to use AWS, so use GCP when you see it fit. And then the next thing you need is the Terraform config.tf file. This is where we configure the S3 bucket for the backend state for our Terraform. Okay, that is good. So I'll save all these files. Now I have my Terraform configured on my local machine because I don't want it to be exposed to the internet. So this is being backed up in my iCloud, so I have total control over my own server configuration. I don't want to expose any sensitive information. But you can also use GitHub Actions for running your infrastructure as well, but I prefer to run it this way for now. So now I will just say Terraform, because I've already initialized. If you just added all these files, the first command you need to run is Terraform init. Then need to say it is initializing. Okay, and then you say Terraform. Let's check if everything is formatted well. Terraform fmt. That is good. Now the next thing we need, Terraform validate. Let us validate it. Terraform validate. Say success. Now let us see which resources it is going to create for us. So Terraform apply. Terraform apply. Okay, it says cancelled, but let's run it again. What was the last command we ran? Validate. So let's run Terraform plan before apply. Terraform plan, so we see the resources before. We always have to run Terraform plan before you run the apply. So Terraform plan, then we see we are going to add 5 resources, and then 0 to change and 0 to destroy. This is very good because sometimes you might make a mistake and then you will be deleting a server. So imagine you are deleting your database server, which is going to be very dangerous for you. So I did it. I know how it feels. So don't, a wise man learns from the mistakes of others. So try and be wise. Then the next thing we will do is to say Terraform apply. Then give it a moment. Say yes. Then now it is creating all the resources for us. So let us give it a moment and then ensure that we get all the resources created successfully. So now it has been 5 resources have been added successfully. So let us go to our AWS account and have a look. So now go to EC2 instance and then let us see the resources that are being created. Nice. So now we have 2 instances that is being created for us. This is good. So we created one for the master node and one for the worker node. So this is the best and smart way to always manage your infrastructure, because you can always replicate and then do this at scale instead of trying to launch every instance and do all the configurations, SSH into the instance, and then run all the commands that you could do. It's going to be tedious, trust me. So I would recommend you to take the time and then try to set your web servers as infrastructure as code. And it can also serve for a disaster recovery purposes. So this is very good. Nice. So let us wait whilst it's initializing. It's still checking. So let us wait. Nice one. So now that we are waiting, the next thing I would like to do is to SSH into our web server and check. So connect and then go to SSH client, copy this, go to your terminal, and then ensure that you have your key perm here, because you need your key perm to be allowed to SSH into your web server. So I'll clear my screen again. I will make this a bit bigger. Hope you can see now. So now I will just run my command here and then say yes. Good. I have SSH into my web server. Now let us check ls no files on my server yet, and then I will check kubeadm version to see if Kubernetes is installed. Confirm Kubernetes is installed correctly. kubectl version, confirm we have Kubernetes component on it, and then I will let us check if kubelet is running. So system ctl status and then we will say kubelets, not kubelets, kubelet. Good job. Now we can see kubelet is running as well. So now, yes, everything is running. So now we can see run k get ports. You can get the ports, all ports. Now we have all ports running successfully. So now you can move on and then deploy your application. So now the next step I am going to show you is to have a feel on how we deploy production grade application onto your web servers using Kubernetes. So I'll clear the screen again. And then, but before we do that, let us see how many nodes we have. So k get nodes. And then you see we only have one master node, and then that is ready. So now we need to join our worker node. So in order to join the worker node, we need to run this command kube adm -h. Let's see what we have. So we have join, and then we have token. So we need a token. So kube adm, clear the screen, sudo kube adm token -h. So yes, so now we can create a token, and then let us run it's create. So I'll clear the screen again so you can see. Clear the screen and then run the last command we did, kube adm token create. Then let's run -h and see what we can do. So now kube adm token creates. Then we have all these flags that we can provide, but we need this one, print join command, so that we can join. So you can read it here. Instead of printing only the token, print the full kube adm join flag needed to join the cluster using the token. So if you want to join another worker node into your master node cluster, you just need to run this command and then get the token. So I will run this command. So clear the screen again. Let's get the last command we ran, and then I'll paste this one here, and then I'll run it again. So now we have this command that we need to run on the worker node in order for it to join the master node. So I will save this somewhere, and then we will also SSH into the worker node. So again, save it somewhere. I'll save mine somewhere, open Notepad, and then put it there. Good job. So now exit your master node server, clear your screen, minimize your terminal, and then also let's go back to AWS console. So AWS console, and then go to instances. Now find the worker node, and then connect also SSH client, copy the example, and then go back to your terminal, and then paste it here. So run it and then say yes. Now we have successfully SSH into our worker node. So let us check if we have Kubernetes installed on our worker node. So kube adm version, before we even run that token we created. Now we have kube adm on it. So kube ctl version, and then let us check if kubelet is running. Clear the screen, system ctl status, and then kubelet. Okay, so kubelet is running on our master node, so that is good. That is good. System ctl. So kubelet is running on our master node. So at least let us check kubelet version. No, I spelled kubelet wrong again. So let's see. It's system oh my god, system CTL status, and then you say kubelets. So it is should be running. Yes, we have kubelets here. So this is a node agent. That is good. Stop it. And then we could see we have a problem with kubelet on my worker node. So it shouldn't be so. It shouldn't be so. It shouldn't be so. Let's restart it. System CTL restart kubelet. Now we need to run it with sudo privileges. So sudo system CTL restart kubelet, and then check the status again. So let us also check if container D is running successfully on our worker node. So system CTL status container, it is running successfully, and see if it's enabled. Yes, it is enabled. So we have a problem with the kubelet. We need to ensure kubelet is running on our worker node as well before we can even move on. Okay, so after looking into it, I think we just need to join the master node so that it will have all the certificates and the config in it for the kubelet to also run. So let us try and run the token we generated. So copy that token and then go to your worker node and paste it there. So it couldn't join because of user privileges. So you have to add sudo and then paste the command. And then now, boom, we could join. Now, boom, we could join we could join the master, we can join the cluster. So that is good for now. So now let us try and see if we can verify if kubelet is also running on the worker node. So kubectl, now system CTL status, and then we say kubelet service, kubelet service. Yes, now we can see kubelet service is running. Good job. Now we can exit our worker node. Exits, clear the screen, SSH into the master node again, and then clear the screen, and then now run get nodes. Let's see how many nodes we have. Now we have 2 nodes, so one master node and 1 worker node. So now that we have set up our infrastructure successfully, the next thing we need to do is to take a break and grab a coffee. And then in the next step, I'm going to show you how I deploy web applications at scale, because I already have my portfolio and I already have some web application services running on my server previously, and then I unfortunately took it down. So now I'm bringing it back again, and then you can also follow similar steps and then run your web applications. So clear the screen, and then I will take a break now.